Whether you've seen the movie Interstellar or you're a fan of astronomy, chances are you've heard of time dilation, but what is it and how does it work? Now in this part, we're really going to focus on one aspect of time dilation, gravitational time dilation. We'll focus on the effects that speed has on the passage of time in the next part. Now you've probably heard that space-time is the fabric of the universe. It's not space and time, but space-time, and mass warps that fabric. And what that means is so that anytime there is mass, it's not just warping the fabric of space, it's also warping time as well. The more massive the object, the more intense the effects. Now, let's say that we have two scientists on Earth who have discovered two planets. Planet A, which has about 1.5 times the mass of the Earth, and Planet B, which has about 4 times the mass of the Earth. They decide that they want to study the effects of gravitational time dilation, and to spice up the plot, they have a device that can instantaneously transport them to these respective planets, and after 1 hour has passed on Earth, it'll instantaneously transport them back. They synchronize their watches and are transported to their respective planets. After 1 hour's passed, they reunite, and to no one's surprise, their watches are out of sync. The scientist who visited the more massive planet seems to have spent actually less time on it than the scientist who visited the less massive planet. Now, here's the crazy thing. Neither of them noticed the difference. The scientist on the more massive planet, where the clock ticked more slowly, didn't feel as though time was slowing down. And the scientist who was on the less massive planet didn't feel as though time was speeding up. Everything was just normal. Their perception of time stayed the same. It wasn't until they had an outside frame of reference where they could actually see, oh, time ticked more slowly on the planet with more mass. This is gravitational time dilation. Now, our scientists, they want to do something big. And so they decide that scientist A is going to go visit the supermassive black hole at the center of our galaxy. Sagittarius A star is the name of the black hole that sits at the center of the Milky Way, and it has a mass of 4.4 million times the mass of our sun. So the effects of time dilation are going to be much more pronounced than between the two hypothetical planets. When the scientist who visits the center of the galaxy returns to Earth, he finds that the 1 minute he spent just outside the event horizon of the black hole has been equivalent to 700 years on Earth. I'm very glad that they didn't ask me to do it, because when I was originally writing out the calculations for something like this, I decided that he was going to spend a year and he would have come back to absolutely nothing. And I know that I've been giving hypotheticals here, but this isn't all just hypothetical. They've actually been able to test the effects of gravitational time dilation here on Earth. Thank you for watching. I try to make topics in astrophysics accessible to a wider audience, and if you'd like to support my work, please like, comment, subscribe, share all this stuff. I'm looking to grow my platform, and I can only do that with your help. Also, stay tuned for part 2, because that's where we're going to start talking about how fast you're going and the effects that that has on the passage of time for you.